Waves 1.3, representing waves graphically. There are two main ways of plotting a wave. The first is displacement against time. So if you imagine something like a slinky oscillating, and you stick a brightly coloured sticker on the wave, on the slinky itself, or one of the coils of the slinky, and you plot where that sticker is as time passes, so it would oscillate from side to side as the seconds tick by. And this is a plot of where it is at any point in time. Okay, so a single point. Now we've got time in seconds on the x-axis. So there's a couple of things you can get from this graph. First is the amplitude. So the amplitude is the greatest distance that the sticker moves from its equilibrium position. So it's sort of the maximum displacement. If you take a whole wave, so from a peak and a trough, right from beginning and end to end, it's the sort of the wave that shape that gets repeated over and over again. Because we've got time on the axis, that complete wave gives you the period. It's the time for one complete oscillation, and it's given the symbol capital T, and is obviously measured in seconds. The frequency is the number of times that period will fit into 1 second. So the number of cycles per second. So the formula for that is F is 1 over T, 1 second divided by the time for one wavelength, one wave. And this is a reciprocal relationship, so you can rearrange it to say the period is 1 over the frequency. So you just swap those two terms. Very useful equation. Displacement against distance is the other way of plotting. So we've got distance on the x-axis this time, measured in meters because it's an SI unit. The amplitude is still the same, it's the maximum distance from the equilibrium position to away from the equilibrium position. If you consider a whole wave this time, rather than time, we've got a distance because that's what's on that axis. So this time a whole wave is the wavelength measured in meters. This time we're considering the wave for a point in time. So it's like a single snapshot or a frame caught on video. And that's it. So you just need to be careful to look at what is actually plotted on this axis, because you'll notice both of these representations of waves look exactly the same. They're the same shape. They've both got displacement on the y-axis. So it's just what is written here that you have to be a bit careful with. Make sure you know which you're looking at.